Hmm. Hello and welcome. I'm Lee Radford, ABC broadcaster and your webinar host today. And if you haven't joined us before, welcome aboard. Great to have your company. I've been in the broadcasting business for over 30 years with the ABC, but these days also am involved in a podcast business with my brother Drew called Events on Air. But lovely to have you join this special seminar today. We've been getting some great feedback about this webinar series, and we hope that it's helping you to build your knowledge about the nutritional value of potatoes as a whole food. This is the last of the Aussie Potatoes webinars for the year. And again today, we'll be hearing from Dr. Jane Watson, who, like many of you in the audience, is an accredited practicing dietitian. Jane will present the latest science about the not-so-humble spud and the glycemic index. But first, let me remind you just a little about Hort Innovation. As the grower-owned not-for-profit and development corporation for Australia's horticulture industry, Hort Innovation exists to drive a prosperous and healthy Australia. It does this by providing the best knowledge and solutions to create a world-class horticulture sector. If you're sharing to social media today, please feel free to use the hashtag Aussie Potatoes and also to tag us at Aussie Potatoes. We've got a particularly active Instagram community, so if you're not already following us, please do. This webinar is being recorded and it'll also be available on the Aussie Potatoes website at www.aussiepotatoes.com. Now, we'd love to hear from you with your questions during this webinar, but please use the Q&A function, not the chat function. If you'd like to get Jane to answer a question, I should say, and she's very keen to do so, she'll do as many as we can get through in the time that we've got available. So please use the Q&A function. So now let me introduce Dr. Jane Watson. Jane's a highly experienced APD with special interests, including paediatric and maternal nutrition, polycystic ovary syndrome or PCOS, and disordered eating. She receives referrals from a range of local paediatricians and general practitioners, and she's held teaching and research roles at the University of Newcastle. So Jane, over to you.
Thanks, Lee. Good to have you on board for this, the third webinar of the series. And I think, well, I hope that the topic today is interesting. I mean, I think we, as dietitians particularly, think that we understand glycemic index, and we are certainly at the forefront of educating people about glycemic index. It's actually not nearly as straightforward as it might seem on face value. And so hopefully throughout the next, 40 minutes or so, I can just give you some of the up-to-date research with regard to glycemic index and potatoes specifically. Now, I know this is going back to what you might have learnt at uni and are quite familiar with, but I think it helps to set the scene a little bit, because when we think of glycemic index, I think a lot of us are used to referring to tables of low, moderate and high glycemic index. But I think we need to remember that those tables are an estimate. So glycemic index, strictly speaking, is the increase in blood glucose level in an individual in relation to a specific food, but relative to a test or a reference food. So when glycemic index is measured directly in an individual, it's their response to that food at that time, and then they're tested at a separate occasion using the test food, and that might be glucose or white bread. And we'll get in a little bit more detail about that a bit later, but the tests are done on 50-gram portions of carbohydrate, and it's really an accurate glycemic index measure is in an individual at that particular time relative to a reference food which is tested in the same individual on a separate occasion. So when we use glycemic index tables, they are an estimate. They're an average of individuals that have been tested, using specific foods and reference foods, but they are not the glycemic response of the individual that we might have in front of us in a consultation, for example. So they're just a guide. Just the science of calculating glycemic index, and I think a lot of you will be very familiar with this, but I guess this is just a bit of a refresher. So the way that we calculate glycemic index is we measure the area under the blood glucose response curve after the consumption of 50 grams of a test food, and then we divide it by the area under the blood glucose response curve after consumption of 50 grams of carbohydrate of a reference food. So glycemic index is expressed as a percentage, and it's expressed as the percentage of a food in the same person on a separate occasion. So this is pretty dry. Hopefully it'll get a bit more interesting than this. Glycemic load is an understanding, I guess it's a more practical interpretation of glycemic index, if you like, because it considers portion size. We don't eat carbohydrates in 50-gram portion lots, and glycemic load recognises that. Sorry, I'm just seeing this. So to estimate the glycemic effect of a portion of food, we would take the glycemic index of a particular food, multiply it by the grams of carbohydrate in that serve and divide it by 100. So glycemic load calculations should be made using GI measured with the same portion size of food. And I don't want to get too bogged down in the detail, but when we look at blood glucose response in relation to carbohydrate foods, it doesn't increase. It's not a linear increase. So let's say you have 100 grams of a carbohydrate. The blood glucose response is not necessarily double what a 50-gram portion would be. So it doesn't increase in direct proportion to the amount consumed. So eating, say, 6 times the amount of bread, we know only results in a 3-fold increase in area under the curve or glycemic index. So it's, again, I guess just to be aware that all of these measures are approximations, because unless we actually measure that specific portion of food in that particular individual, we are only having a really rough guess at what a glycemic response or a blood glucose response might be. Because we like to categorise things according to, put them into neat boxes, the broad classifications, if you like, for glycemic index and glycemic load are shown here. So glycemic index, a low glycemic index is considered anything under 55, a moderate between 56 and 69, and a high glycemic index over 70. Now, we'll have a look in a few more slides' time, but potatoes actually fall across all 3 categories for both glycemic index and glycemic load. So you can see here that glycemic load, a low glycemic load is under 10, a moderate is between 11 and 19, and a high glycemic load is over 20. But although it sounds really simple to classify foods according to whether or not they fall into these categories, it's actually not simple at all. And we will have a look, but potatoes do fall into, depending on, when you test, how they're cooked, all of those sorts of things. Potatoes have a highly variable GI and therefore GL, and they fall across all 3 categories. Australia has been at the forefront of glycemic index research, and the International Glycemic Index tables were first published by Kay Foster Powell and Jenny Brand Miller, who have been involved in the or authors of the subsequent updates of those tables. They were revised in 2002, and the most recent tables are from 2008. So I actually really encourage people to have a look at that. It's publicly available at open access, that 2008 paper with the international tables of GI and GL. And I think it really helps to remind us of the variability in glycemic index. And you'll see there are pages and pages of the glycemic index and glycemic load for lots of different foods that have come from reliable sources. So it's a really neat compilation of what we know to date, or the data we have to date, and it shows large variation, and particularly in potatoes, which we'll have a closer look at soon. There's also, on the University of Sydney website, a searchable database. So you can type in potato, for example, or chickpeas, or whatever it is, and it'll bring you back all the matches of the data that's available in Australia for the glycemic index of those specific foods. So that's a pretty neat resource. But I think it's really, yeah, it's a good reminder just to that GI is not a simple concept, and that having a look at those tables really demonstrates that when, you know, there are so many factors that influence GI, that you can see that it's actually really tricky to group some foods into low, medium and high, and potatoes are certainly one of those foods that are very tricky to categorise. And potatoes actually have the most variable glycemic index of any food. When I searched on the University of Sydney searchable database, I then collated this graph based on all the matches that were made for boiled potatoes. And you can see here, I've just classified them according to how many potatoes fell into the low, that yellow bar on the left, the medium range for GI, so the blue bars, and the high GI range with the green bars. And you can see that over half of them, so 65% of the potatoes, boiled potatoes on that database, have a glycemic index between 50 and 79. So they cross between the medium and the lower end of the high glycemic index range. But you can see there are also potatoes that are very high and also potatoes that are low glycemic index. And in the international tables paper that I referred to earlier, the potato glycemic index data has an enormous range. So it ranges from 23 to 118, which is such a big variation in glycemic index. And glycemic load for 150 gram serve has a huge variation as well, so between 8 and 26. So we can see that, you know, it's complicated, and it's really, really difficult to say one way or another for any specific potato that someone might be eating in their house, in their meal, what the glycemic index might be for that potato. So the variability in glycemic index generally, and not just with regard to potatoes, can be a result of a range of factors. So firstly, the testing methodology and conditions, whether the blood samples are from veins or capillaries, and some of the lab methodology that might be used will all impact on the glycemic index that's calculated. The reference food, so the international standards specify glucose as the reference food, but there is still discussion about the suitability of white bread versus glucose for glycemic index calculations for various foods. And so we need to be aware that the reference food has a bearing on the glycemic index. In fact, to quite a large extent. So when bread is used as a reference, it gives glycemic index values that are 1.42 times higher than if glucose is used as the reference food. The other factors impacting on glycemic index are the physical and chemical characteristics of the food, and we'll have a look at that in relation to potatoes in a little bit. But fibre, I mean, I think we tend to think that the higher fibre is, the fibre content in a food, the lower the glycemic index, which is certainly the case for soluble fibre, but it's not always the case for insoluble fibre. So sometimes highly processed breakfast cereals that are high in fibre still have relatively high glycemic index measurements. So yeah, there's lots of variation there as well. As you all probably know, how we prepare and process food has a big impact on glycemic index as well. We'll have a look at that in relation to potatoes specifically, but certainly the more processed a food is, generally the higher the glycemic index is. There's still a lot that's not known about why that's the case. It seems that possibly breaking down the food matrix means that digestion occurs more quickly and glycemic, blood glucose response is spikier or, more rapid. But there are lots of unknowns. The combination with other foods in the same meal is a really powerful influence, and I've got some data to show you with regard to that for potatoes specifically. But when there's protein, fat, fibre, other nutrients and compounds that are combined with carbohydrate foods in the same meal, that influences glycemic index. The portion size of the food, of course, impacts on glycemic index. And I think, being humans, we don't necessarily eat foods. We can do these measurements in labs, but when it comes to serving it on the plate for your meal, then there can be quite a variation in portion size, even in the same person from one meal to the next. So that influences glycemic index as well. And just to add to all of those factors that can have a bearing on glycemic index, our individual blood glucose response varies from one day to the next according to, other carbohydrate foods that we've eaten, our exercise, our metabolic health. There are so many factors that influence blood glucose response within the individual and also between individuals. Lots of things to consider and wrap your head around when you're thinking about a concept that may seem quite straightforward and really simple. And I think as dietitians, our responsibility is in distilling some of those messages so that people can make informed choices and not, limit foods that are really healthy because of their glycemic index. We know all carbohydrate foods will have a glycemic index, but it doesn't mean we don't eat carbohydrate foods. They're a really important component of a healthy eating pattern. So I think, just understanding a little bit more about glycemic index can be really helpful for helping inform clients or educating people about how glycemic index fits with regard to their food choices. We're going to have a quick break from the presentation, so I'll just go back to you, Lee, for a few minutes.
Thanks very much for that, Jane. Fascinating stuff. And I tell you what, I am certainly learning a lot. It really is it's very interesting. It's raising lots of questions in my mind, and I'm keen to ask you a few at the end of the presentation, and I bet other people are as well. If you are, we'd love to get your questions as we go. So please use the Q&A function, not the chat function, if you wouldn't mind, the Q&A function to type in some questions. We'll gather those and put them to Jane at the end of the presentation. So please don't hold back. Back to you, Jane.
Thanks, Lee. Now, if we have a look at glycemic index in relation to potatoes specifically, it's a whole lot more interesting than you might ever have imagined. The glycemic index varies by variety, which I guess is no surprise. There are some new varieties of potato, new cultivars, that have lower glycemic indexes than possibly other varieties. And so the Charisma and the GI Licious have what we would classify as lower glycemic indexes. And the Spudlight has lower carbohydrate content. So, there's been some really interesting stuff being done with regard to altering GI and carbohydrate contents in potatoes. The other factor with regard to potatoes that influences GI is how old they are, how long it's been since they were picked, because the starch content changes a little bit, what sort of storage conditions, and the processing. And I've added plus there because obviously, with more highly processed potato products, we're more likely to have a higher glycemic index. But that's not a given either, because it depends on what else they're combined with and, all sorts of things. But generally, highly processed products will have a higher glycemic index. Interestingly, and some of you may not be aware of this, but pigmented or the coloured potatoes have a lower glycemic index. It seems that the polyphenols which are in potatoes reduce that. It's the polyphenol content that contributes to the reduced glycemic index, but the mechanism doesn't seem clear. And there are a few mechanisms that have been suggested as being responsible for that reduction in GI. And one of them is that the starch and the polyphenols form a complex that's resistant to enzymatic digestion. So the enzymes just can't break down that matrix, if you like, of starch and polyphenol. That digestive enzymes like, salivary amylase and pancreatic amylase are inhibited, with the presence of polyphenols, and possibly also that there's reduced glucose uptake. So again, it's early days as far as understanding some of the science behind glycemic index and potatoes, but the coloured varieties are consistently showing lower glycemic indexes. And the polyphenols are present in the whole potato, the peel and flesh, but they're higher in the peel. Now, I know a lot of you are probably quite familiar with this, the cooking method and its influence on glycemic index with regard to resistant starch, which we covered in the previous webinar. So cooking and cooling potatoes increases resistant starch, and the higher the quantity of resistant starch, the lower the glycemic index. Cooking methods, there's really no clear pattern as far as what sort of cooking method equates to what sort of change in glycemic index. So whether or not potatoes are boiled, baked, microwaved or mashed, I mean, we would kind of assume that mashing might break down the structure so that there's a higher glycemic index, but that's not borne out in the research at all. So results are highly variable and not consistent. And with the combination with other foods is pretty clear that any foods that are combined with potatoes that contain fat or protein or some fibres, vinegar, peanuts, lemon juice will reduce the glycemic index, glycemic load of that meal. So, you know, having, say, a massaman curry with peanuts and some olive oil in it would contribute to a reduced GI in that meal. Certainly if you had, say, boiled potatoes that were then cooled and made a potato salad with a vinaigrette dressing, you might have vinegar or lemon juice, that would contribute. But then really any way of eating potatoes combines other foods. I mean, we don't tend to eat potatoes on their own. Not many people would do that. So they're part of a meal, and we know that as part of a meal, the GI of potatoes is much, much lower. And also the fact that, I think potatoes generally, there's a notion that they are high GI and high carbohydrate, but potatoes actually have lower carbohydrate than some of our other carbohydrate-rich foods like pasta and rice. And so that contributes to a lower glycemic load because there's a lower portion of carbohydrate in potatoes than in many of the other carbohydrate-rich foods. So I think potatoes have been slightly unfairly kind of labelled as these really, really high carb, high GI foods. Just a little bit of biochem. I'm revisiting this slide from the resistant starch webinar last week, but the reason for doing that is it relates to glycemic index as well. So the starch in potatoes is made up of amylose and amylopectin, and amylose is digested a lot more slowly. So the amylopectin with the branched chains breaks down more quickly. So the higher the amylose content, the lower the glycemic index. So you can imagine that if those long chains take longer to break down, so the more of the long chains rather than the branched chains, the lower the glycemic index. Now, potatoes have a really variable amylose content, and estimates have ranged between 20 and 43%, which means that the formation of resistant starch is highly variable, and that impacts on glycemic index. So back to one of the slides earlier, that as potatoes mature, it's the proportion of amylopectin that increases if we store them for longer periods of time. So that could potentially, we would expect that then the glycemic index might be slightly lower in really fresh potatoes as opposed to potatoes that you've stored for a longer period of time. So yeah, when potatoes are cooked and cooled, it's the amylose that forms the resistant starch, which contributes to a lower GI. So it's that amylose content which determines the extent of formation of resistant starch, and therefore the impact on glycemic index when we eat cooked and then cooled potatoes. I think it's worth just mentioning this because we hear terms like rapidly digestible starch, slowly digestible starch. What is it and how does it relate to potatoes? So when potatoes, well, before potatoes are cooked, so raw potatoes contain starch, of course, but it's not easily digested at all. It's the cooking process that means starch changes form into rapidly digestible starch, which we can easily digest. As potato cools, and this is in that bottom right-hand corner, when we cook and cool potatoes, through the process of cooling, the rapidly digestible starch reduces as a proportion, the slowly digestible starch increases, and the resistant starch increases. So this has a major impact on glycemic index, because rapidly digested starch is digested within 20 minutes, the slowly between 20 and 120 minutes, and resistant starch not at all. So you can see that depending on the proportions of each of these three types of starch, the glycemic index could be highly, highly variable. This slide is from the resistant starch webinar last week as well, but I wanted to just revisit it because I think it's a good reminder that when we look at the fibre and resistant starch in potatoes compared to other foods, that potatoes stack up really well. So the bar at the top is showing our project data. Part of this project was to test the nutrients in potatoes, particularly fibre content. And the bar at the top showing our project data shows the insoluble fibre in blue, soluble fibre in orange, and resistant starch in grey. And you can see that potatoes contain a high quantity of all three of those types of fibre. And when we look at what a medium potato contains, so a medium potato, we've used 140 grams, which is a little bit smaller than a tennis ball. But as a serve, a medium potato is considered a very high fibre food. It contains 7.7 grams of fibre, which is over a quarter of our daily intake, our daily requirements. So, potatoes are a really, really good source of fibre. All of those, I should just make mention that all of the data on that slide is Australian data, and it's also the resistant starch method is the same for all of the foods. So the way we tested for resistant starch for the project was the same as for the foods that are available on that graph. Now, glycemic index is based on 50 grams of available carbohydrate. I think we generally consider potatoes as a good source of carbohydrate, possibly a really, really high carb food. But when you look at how they stack up against other carbohydrate-rich foods, which I touched on earlier, the carbohydrate content is much lower. So this graph shows the carb content per 100 grams in the blue columns and per cup in the green columns. So potatoes on the far left, and when you compare it with pasta, so wheat pasta, the next one's gluten-free pasta, rice, white rice, brown rice, and wholemeal bread, you can see that the carbohydrate content per similar, the same serve sizes is a lot lower in potatoes. And I've just put a comparison on the right-hand side to indicate how much food is required to get 50 grams of available carbohydrate. So for potato to have 50 grams of carbohydrate, it would require a serve size of 225 grams of potato. So that equates to 3 Australian Guide to Healthy Eating serve sizes, which are 75 grams each. And that's quite a lot. I'm just thinking, the medium potato that we had in the previous slide, which is a bit smaller than a tennis ball, was 140 grams. So it's sort of 2.5 of those. And when you compare that to the quantity of rice, pasta, and bread, you can see that there's much higher carbohydrate content in those foods, which means that to get the same amount of carbs, you are eating smaller amounts. I think it's just important to remember that when we think of glycemic index, it's clearly relates to the carbohydrate portion, but there's not as much carbohydrate in potatoes as we might sort of commonly think. So glycemic index and glycemic load is actually quite a complicated association. I think it's no surprise to hear that watermelon, even though it has a higher glycemic index, has a lower glycemic load. because we know that it takes a lot of watermelon to, you know, to equate to a 50 gram or a, you know, certain percentage of carbohydrate. And potatoes actually fit into the same category in that they have lower portions or proportions of carbohydrate, which means that their glycemic load is relatively low in relation to other foods. And we also know that there are plenty of low glycemic foods that can have a higher glycemic load. So just looking at glycemic index is not necessarily very helpful unless we're taking portion size into account, and that foods with very different nutrient profiles, like, you know, good healthy carbohydrate rich foods like, you know, potatoes and pasta and rice and bread can have similar glycemic index and glycemic loads to, say, chocolate bars or packets of chips. And I think there's we don't need to go into the details of why one might be a better fit in a healthy eating pattern than another. This graph is from a paper by, or published in Australia. Kay Foster-Powell's one of the authors, and it's a really good, I think, indication of how glycemic index and glycemic load might differ greatly. So at the top, there's a comparison between watermelon and ice cream, so regular high-fat ice cream, and it shows that the glycemic index for watermelon is higher, it's 72, glycemic index for ice cream is 37, so it would be considered low. But when you look at the serve size that's eaten and the available carbohydrate, it gives a glycemic load in that right-hand column that's exactly the same for both. So if we were choosing foods based just on glycemic index, you know, we might be tempted to think that ice cream was a better option. But when we look at how it equates to the quantity we eat and the other nutrients that are in that food, then using glycemic load can be more helpful, but also considering the overall context of the food in terms of nutrient contribution and satiety, and, you know, all of those other factors that we consider when we're making food choices. Glycemic index is only one factor. So any carbohydrate food, low, medium or high, can have a high glycemic load depending on the amount eaten and the carbohydrate content. Now, I guess the formula that's generally used to calculate the glycemic index of meals is to add the glycemic index of all the foods. So let's say there's some potato and there's some, you know, carrot, or there are crumbs on meat, or whatever it might be. The formula or the approach taken to estimate the glycemic index of that meal would be to just add the glycemic index of each of those foods. It seems that that is not a good indication of overall glycemic index of meals, and there's something else going on in terms of the interaction of all of those foods, which means that just a simple sum of glycemic index of the foods doesn't predict the meal glycemic index. And it tends to overestimate the glycemic index by 20 to 50%, which is a huge differential. The table here, which is taken from a paper that was published a few years ago, but what they did was tested a 50-gram portion of carbohydrate on its own, the glycemic index, in individuals, so they had 30 participants. And then they tested the glycemic index of a 50-gram portion of potato again, but as part of a meal with chicken breast and carrot and peas. And so in that right-hand column, you can see the huge difference between the glycemic index of potato on its own in this study compared to the glycemic index of the meal. So the glycemic index of potatoes, hopefully everyone can see that, is 72, but in the meal, it was 53. So, it's that interaction with other components in the meal is hugely important and reduces glycemic index well below what estimates would suggest. And the same thing was found in this study with rice on its own compared to rice in a meal, and spaghetti on its own compared to spaghetti in the meal. So it's not possible to predict the glycemic index of mixed meals. So given all of those variables with regard to glycemic index, the World Health Organization and FAO have published a scientific update on glycemic index and carbohydrates in human nutrition. And these were the conclusions that they've come to with regard to glycemic index, so the current position, if you like, that there may be some benefit as far as glycemic control in diabetes and lipid management from choosing lower glycemic index foods, and that it's most appropriately used as a guide to food choices when considering foods that are very similar. So, you know, different types of bread or different types of rice, but not necessarily when you're comparing between foods like that watermelon and ice cream example. And that it should be interpreted in the knowledge of the inter and intra individual variability. So that is understanding that there is variation between individuals, and there is variation even in the same person from one day to the next. And also that GI is only one factor with regard to the nutrition of a food, that, you know, we don't say that something's a bad food because it doesn't contain calcium, for example. That classification of foods as kind of good and bad really negates our understanding that a variety is so important. So GI, I think, is similar. It needs to be considered in the context of other nutritional indicators or other nutritional benefits and contributions from that food. I think the other thing to consider is that potatoes are highly satiating. So this study, I'm sorry it's not a very clear slide, but on the left-hand side there are a list of all sorts of carbohydrate foods, and there's a really wide variety. So in that top group, croissants and cakes and biscuits. In the next group, you know, chips, ice cream, jelly beans, lentils, cheese, eggs, and so it goes on. What I've circled is potatoes, and so that it's indicating that when people ate portions of these foods, it was potato that came out so far ahead in terms of being really filling and satisfying, highly satiating. So that needs to be kept in mind as well, that when potatoes, you know, when we eat potatoes, they tend to really fill us up and make us feel satisfied and probably reduce our intake of other foods. So that's a really important quality, and it's something that's been shown consistently that potatoes are highly satiating. And they're also nutritious. They contribute a vast range of nutrients. You know, they're high in fibre, they're a good high quality carbohydrate. They contain vitamin C, potassium, vitamin B6, folate and magnesium. The other thing to consider about potatoes is how easily they are to access and how popular they are. So they provide a really valuable contribution to the nutrition intakes of Australians. They're in the top 5 foods of contributing to fibre intakes. So they, you know, and I think people are not necessarily, I mean, potatoes have been around for so long, for civilizations have relied on them, haven't they? But I think it's easy to forget their importance in terms of our nutrition and their contribution to our nutrition intakes. And I'm revisiting this slide from the previous webinar as well, but I think just as a reminder that fibre intakes are so important, and given that potatoes are a huge contributor to fibre intakes in Australia, that you know, it's just good to remember that the advice to eat more fibre hasn't changed. There's a strong link between fibre intakes and the prevention of chronic disease such as cardiovascular disease and diabetes risk, and also that relationship between fibre intakes and management of cholesterol, blood pressure, diabetes, and also the contribution to our gut bacteria, which is becoming a real area of interest, and the different types of fibre and the importance of variety of fibre. That little box just shows that linear relationship between fibre intake and reduced risk of certain chronic diseases. So this study was a huge systematic review and meta-analysis involving hundreds of thousands of people, and it really clearly showed that for every 8 grams of fibre consumed per day, in addition to what people were already consuming, contributed to a 19% lower risk of heart disease, a 15% lower risk of type 2 diabetes, and an 8% reduced risk of colon cancer. So, I think we need to remember that fibre only comes from carbohydrates. Carbohydrates are an important contributor to our nutritional intakes and to our health and our disease risk. Oh, I did just want to include this graph because I think we sort of have this widely held notion that potatoes have the same energy density as lots of other foods, and I touched on it earlier, but this graph just demonstrates that for a 100-gram serve of our common carbohydrate-rich foods, the potato has a lower kilojoule intake than many of those foods. So from left to right, that's potato on the far left, then the wheat pasta, gluten-free pasta, white rice, brown rice, and wholemeal bread. And one of the reasons for that, for the low energy density of potatoes, is that they have a high proportion of water, so 80% water. So in summary, GI is beautifully simple, and it seems so simple to be able to refer to charts that have low, moderate, high carbohydrate, glycemic indexes for different carbohydrates. But I think when you dig a little deeper, it is, for potato particularly, it's really difficult to categorise potatoes according to any of those low, medium or high. There are so many variables, and that the glycemic index needs to be considered in the context of other nutritional indicators and contributions. And the potatoes are a high quality carbohydrate, they're high in fibre, they contain resistant starch when we cook and cool them, and that contributes to a lower GI. That coloured potatoes have a lower GI, and really ultimately, and if you don't take anything else away from this session, I think the main thing is that it's our eating patterns. It's not specific nutrients or glycemic index or even individual foods. It's our overall eating pattern and the importance of including a wide variety of highly nutritious foods that is what gives us those health benefits. And potatoes fit beautifully into a really wide variety of whole foods. Over to you, Lee.
Thank you, Jane. That's been a really interesting presentation. Really appreciate it. Lots of thought in behind all of that for sure. Now, there are some questions, and if you'd like to ask a question of Jane, please feel very welcome to do so. We'd love to receive your questions. And if you could use the Q&A function on Zoom rather than the chat function, that is the best way for us to get those questions. So please don't hesitate, type away. But Jane, there are some questions already, and I think one of them is around how you actually should classify potatoes when it comes to glycemic index when you're educating people. I sort of got some mixed messages out of that myself, I must confess. I'm not really sure whether they're low, medium or high. So how do you best explain that?
I think, and I can understand the confusion, I might just go back to a slide here if I could. Here. I actually think it's really difficult to classify them according to any of those categories. So from this slide, you can see that they fall across all categories, even for something quite specific, a boiled potato that's grown in Australia. So I think in a similar way, dietitians are used to people asking whether foods are good or bad. And you'll never get a straight answer from most dietitians about good or bad foods, because it's really problematic to pitch foods against each other and also to how do you classify, on what basis do you classify something as good or bad when nutrition is so broad? So I guess I don't think you can classify potatoes as low, medium or high. I think they fall across all categories. And I think if it's important, you know, if people are, someone with diabetes, for example, I guess some of the strategies that we touched on as far as including other foods, you know, having a smaller portion and including it as a mixed meal, there are strategies that can help with reducing glycemic index in a meal, and really ultimately, if it's blood glucose that's important, then testing blood glucose and understanding what an individual's response to a specific meal or a specific food is probably the best way to go. So I think, I don't know whether that's cleared up any confusion at all, Lee, but I think potatoes fall across all those categories. It's really difficult to classify them, and I think that's why there's that preference to just eat a variety of food, consider portion size, and if blood glucose response is important to someone, then get them to test their blood glucose levels and see what actually happens for them.
Yeah, I think that's probably the best possible advice, isn't it? And it's like a lot of things in life. The answer is not always straightforward, and that appears to be the case here. Now, also, there's another question about sweet potatoes, Jane. And I think you mentioned in the presentation that they have a much lower GI than white potatoes. Now, why is that?
Well, actually, back to this slide, the International Tables paper, the 2008 paper that contains glycemic index data for a whole range of foods, actually shows that sweet potatoes have a really variable glycemic index as well. So theirs was from 44 to 102 for glycemic index. And then for glycemic load, the range was something like a 10 to 40. So a big range. So I guess sweet potatoes have got this kind of superfood status, which I love, because I think any, you know, whole food that's grown in Australia deserves, you know, I think that's it. They are superfoods. But I think we could also hold the white potato in the same esteem, because they're almost nutritionally identical. Their glycemic index is highly variable, and they both form part of a really healthy intake. They're contributing lots of valuable nutrients. They're very similar nutritionally, other than beta-carotene, which gives sweet potatoes their colour. But I would use sweet potatoes and white potatoes interchangeably, and I wouldn't differentiate based on glycemic index.
Jane, there's a question too about diabetics. Now, how do potatoes fit into the diets of people who are diabetic?
I guess, as for all other carbohydrates, in that people with diabetes, as for all of us, we need some carbohydrate in our meals. I think back to the previous question about glycemic index categories, I think I would just encourage someone with diabetes to test their blood glucose level before and after a meal and see what impact that particular meal has, and then work with the dietitian to, if there is a high glycemic or blood glucose response, understand why that might be. Is it the portion size? What else could be combined with that meal to help reduce their blood glucose response? With regard to potatoes, leaving the skin on, eating them cold or reheated. I think they certainly fit. I would never suggest that someone with diabetes avoids potatoes. In fact, I think from this presentation, you can see that there's a really good argument for including potatoes, given that they're so nutritious in so many ways. But given the wide range of glycemic index, I think I would just suggest to people to test their individual blood glucose response, and then talk to a dietitian about how they might be able to modify meals so that if they are getting a high blood glucose response, that they can reduce that somehow.
And Jane, you mentioned that potatoes are highly satiating when they're consumed. does that effectively mean then that if you are eating potatoes, you're less inclined to want to eat more? Effectively, you're not going to go hunting for extra food?
Yes, absolutely. So if something's filling, and I see this in clients that are cut out carbohydrate foods, that they might have a meal that has virtually no carbohydrate in it, but then they're still really hungry. Whereas if they'd had a meal that had contained a good high quality carbohydrate, they might not be hunting around after dinner for something sweet. And potatoes, yeah, because they are highly satiating, just help fill us up and stick with us a bit longer, as they stick to our ribs, and we get good mileage out of them.
It sounds to me like, you can eat as many potatoes as you like. They're going to be highly nutritious and you're never going to get fat on them, Jane.
I think that's a good message, Lee. I think with everything, your dietitians are all about moderation, aren't we? But, we don't eat potatoes on their own. They're part of a meal. They're a really important part of our intake. And I would hate to think that anyone's not eating potatoes because of the glycemic index or the carbohydrate content or the energy content, because I think we've just seen in these slides that, we need to rethink those or re-explain those widely held notions about carbs and potatoes.
Well, I've always been a bit of a potato fiend, Jane, so I'm pleased to learn through the seminar today that I've actually been unintentionally really on the right track. So very comforting indeed. Look, thanks again for everyone joining us on this webinar today. Jane, thank you so much for your presentation and for being able to answer the questions that have been raised. Don't forget to follow us on Instagram or Facebook at Aussie Potatoes. At the end of the seminar, there's also a quick survey that we'd asked you to complete if you would be able to do so. It won't take very long and it's great information for us to receive here for the future. Also, you can visit aussiepotatoes.com for resources and evidence-based information and to find out much more about the not so humble spud. So thanks for your company. Bye for now.